All right, today we are talking about inheritance in Java. So across this whole unit, we're going to be investigating one of the 4 principles of object-oriented programming, which is inheritance. So object-oriented programming is this idea upon which the Java programming language has kind of been built. All of Java is built to service these different principles. So here we're going to be talking about inheritance. And to begin our discussion, let's imagine we have a person class. What kind of information might we need to know about any particular person? Huh? Their name, absolutely. Gender. Age. All right, those seem like very, very good data points. Let's say we have a very, very simple class. We're going to keep track of someone's name and how old they are. We're going to keep track of their birthday. We're going to have those be our instance variables in our person class. So here's an example person class. We'd have our private string name. We'd have our private string birthday. Very, very simple content here. Now the relationship between our person class and its instance variables is called a has-a relationship. A person has a name, a person has a birthday. That's the word for this relationship. Now, another type of relationship that exists is the is-a relationship. In an is-a relationship, we have 2 classes where one of them is a more specific example of the other class. For example, we could have a student class. If we made this student class, we could say that a student is a more specific example of a person. All students are people, but I am not a student. I am a person, but I'm not a student. So student is a more specific instance of the person class. So a student is a person. And like I just said, this relationship is not symmetrical. All students are persons, but not every person is a student. Some persons could be teachers, some persons could be workers, but all of those things are persons. Not all persons are each of those things. So our person class is more general, where our student or teacher or worker class would be more specific. And there's lots of different is-a relationships that exist. A dog is an animal. A square is a rectangle. A Toyota is a car. A car is a vehicle. We have a kind of chain here where we're going increasingly specific. So is-a relationships exist throughout the world. There's increasingly specific examples of different things. So some behaviors or methods that we might share between a student and a person object might be getting their name, calculating their age, things that any person or any student should be able to do. And there are some actions that would be exclusive to students that people in general would not need to have. For instance, getting what their GPA is, finding out what grade level they're in. Not all people are going to have that information associated with them. So we don't need the person class to have that kind of information, but every student should have that information tied to them. Now, what if we made a teacher class as well? A teacher is also a person, just like a student is a person. And just like the student class, our teacher class would have some commonalities with our person class. Both the teacher and the person be able to get their name and get their age or calculate their age. But a teacher you might need to know what classes they teach. You need to know what their salary is. So those pieces of information wouldn't belong to a student. Students don't teach classes. Students don't collect a salary for going to school, but a teacher would need to know that. So we have distinct information in our different classes. So all of this is leading up to how we can implement this. We can make the classes that we write have this is-a relationship by using the extends keyword. And this creates what we call a class hierarchy. We can place all of the common attributes and behaviors into one class, all of the things that multiple classes are going to share. All of that information can go into one class, which we call a superclass. And all of the more specific classes, teacher, student, whatever, these will be what we call subclasses. And they'll each have their own individual attributes and behaviors. Yes?
So would the superclass be like person.java and then the subclass be like teacher and student.java?
Absolutely correct, yeah. So this relationship that exists will allow us to reuse a lot of code without needing to rewrite it. So we can use all the code in a person within a student or teacher without needing to rewrite all the stuff in person. So if we look at our hierarchy, this is what we can kind of imagine. We have a person class, and we'd have student and teacher classes, both of which would extend the person class. So a student would have access to all of the stuff in person, a teacher would have access to all the stuff in person, but they wouldn't be able to touch each other. So here we have the person class would be our super class. All of the common behaviors between all of the classes are going to be placed in our person superclass. And then teacher and student are our subclasses. So subclasses are going to inherit, they're going to have access to implicitly all of the public attributes and behaviors from their superclass. So any methods, any things that are declared as public within a person, anytime you have a student or teacher object, you can just use those methods, use those variables if they're public, as though they belonged to the student or teacher class. So if we think about what kinds of things each of our different classes has, a person has a name and a birthday, a student has a name, has a birthday, has a grade level and a GPA, and a teacher has a name, a birthday, a list of classes they teach, and a salary. So our name and birthday are shared between all three, and then each of our two subclasses has its own distinct attributes. So when we actually implement this, our superclass, we don't have to do anything special to make a class be a superclass. So we would just create our public class person like you would normally create a class. Just like any class we've created so far, we can use that as a superclass. To make a subclass, we're going to make our class name public class student, and then we use the extends keyword. That is what's going to make this be a subclass. And then after extends, we need to say which superclass is being extended. Yes?
Where do all the functions go? Where does get name?
So all of the methods and stuff per person would belong in person, but I'll show a more specific example later. So student is going to extend person, saying that all of the stuff in person is also going to be accessible from inside of student. Now, one thing to note is that a subclass can only extend one superclass. One subclass can't have multiple parents. You can only have a chain going down one at a time. You can't say that student extends both person and human if you had those as separate classes, for example. So if we were to look at what the person class might look like, we would have our private instance variables, name and birthday. Our constructor would initialize those. We would have our get name, we would get birthday, calculate age, whatever other methods we need in the person class. So person class, like I said, superclass, you don't have to do any extra stuff to make it be a superclass. Now our subclass, our class student extends person. And inside we have our two instance variables. We have our grade level we have our GPA. Now, keep in mind, we don't need to create those private variables, name and birthday. Those belong to the person class. We don't have to create those. Now, we do want to get them in our parameters for our constructor because a student will have a name and a birthday, even though they're not private instance variables within this class. So we'll still accept those parameters, but those values aren't found in the student class. So we're going to actually pass those upwards into the person's superclasses constructor using the super keyword. And we're going to cover constructors more next class. So for today, most of the assignments you're going to work on, I don't think you're going to have to make any constructors. Next class, we're going to talk about inheritance and constructors. But just keep in mind, when we're creating a student, we're still going to need those attributes that belong to a person. So when I actually create a student object, my student equals new student, Edward, birth date, grade 11, GPA 4.5. If I print line my student.getName, that's totally fine. Even though in my student class, I didn't implement the getName method, because it's extending the person class, it has access to that getName method built into the person class. So all of the behaviors, all the public things from person are usable within a student object. So that lets us create more specific versions of classes with more functionality inside of them, more specific functionality. And like I said earlier, one subclass can only have a single superclass as its parent. You can't have multiple parents, but you can use a subclass as a superclass for a different class. You can have a chain going downward. So if I have my student class extend the person class, I could, for example, have the high school student class extend the student class. So I'm creating a chain of subclasses. So here, student would both be a subclass to person. It would also be a superclass to high school student. So high school student would have access to all of the public things from both student and person, because that's how inheritance works. We have access to all of the things from our parents. So, brief recap. We can create a hierarchy of classes that will allow us to reuse common attributes and behaviors. A subclass uses the is-a relationship, which signifies it is a more specific example of the broader superclass. We use the extends keyword to establish this superclass subclass relationship, and one subclass can only extend a single superclass, although that subclass can be used to extend, or can extend to another subclass. So you can have a chain of subclasses going downward. Does this topic make sense? Any questions on any of that? Cool? Cool. All right.